Here we're going to talk about how to find the area of a rectangle and of a square. And so the formulas are on your formula sheet, so you don't need to memorize them, but you need to know how to apply them when you're using the formula sheet. So the area of a rectangle is LW. Length times width is what those two letters stand for. And remember, when you have two letters beside themselves, that means multiplication. So this is length times width. So if you have a rectangle, remember what a rectangle is. It has four 90-degree angles. It looks like a box. The two sides that are going up and down have the same length and are parallel. The two sides that are horizontal are also the same length and are parallel. It really doesn't matter which side you name length and which you name width, as long as it's one of, one's the bottom and one's the side. So normally the longer side you name length and the shorter side you name width. In a square, remember, a square is a special case of a rectangle. It has four 90-degree angles, looks like a box in which all of the sides have the same length. So they all have the same length. They're also obviously parallel. These two are parallel, these two are parallel, just like in a rectangle. So when you see A equals S squared, that's the formula that's on the formula sheet. What it means is S stands for side. So if they tell you the length of one side, you know the length of all the sides because they're all equal. So if this was 5, every side equals 5 because that's the definition of a square. All the sides are equal. So when you're taking the area, you just take the side and square it. And so if you don't know how to square something, you need to watch the video on exponents. So also remember what area is. So if you want to think about area, you can think about it like you're covering something. For example, you're putting carpet on a floor, you need to know the area of the floor. If you're painting a wall, you need to know the area of the wall. So you're essentially, you're filling something in or covering it. Whereas if you think about perimeter, perimeter is the measurement of the outside of the shape. Area is a measurement of how much you need to fill the inside of the shape. Another thing with area, and you'll see them when we do some problems here, is that the answers are always in square units. So if your measurements are in feet, it'll be feet squared. This can also be a key to you. If in a word problem they talk about square units, you should automatically, think, oh, maybe I should be doing an area problem. So, for example, here we have a rectangle with a length of 10 feet and a width of 4 feet. What's the area? Area is length times width. Our length is 10, our width is 4. So 10 times 4 is 40, we're in feet, so it'll be feet squared. That's how you write the units on it, because it's feet times feet. That's how you get feet squared. Every area problem will have a squared on whatever unit of measurement you're using. Let's say we have a square and it's 9 meters. Well, in a square, you just take the side and you square it. So area equals 9 squared. Again, if you don't know how to do this, watch the exponents video. 9 squared is 81 meters squared. Now remember that the square is just a special case of the rectangle. It's just like a rectangle, except all the sides are equal. So if you want to, if it's easier for you to think about, instead of thinking of it as S squared, you can still think of it as length times width. Because remember, we know if this side is 9, we know that side is 9. So if you want to think of it as length times width, then area equals 9 times 9, which is, again, 81. So you're obviously going to get the same answer. It's just how you're going to think about the problem. So this is a pretty straightforward process to find the area of a rectangle. Just length times width, side squared, or you can also think of it as length times width, side times side, that's side squared. But the problems you're going to get on the test are likely not going to be this straightforward. So we're going to do 3 word problems and apply these concepts, but they're going to be a little bit, more complicated. So I'm going to take a pause and put a problem on the board. Okay, so here's the word problem that is going to test your knowledge of area. And a lot of times when people see word problems, they kind of get freaked out, but really just, you need to read it, maybe you need to read it twice, and think about what it's asking you. So, John wants to build a bookshelf in an office that is 12 feet by 15 feet. The shelf will go along the entire wall of one side. The shelf is 1 foot deep. Which wall should John build it against to maximize floor space? So we want to have the most floor space, and so that's kind of the, can think of that as an area problem because it's how much space you have inside. So again, read the question again and think about what are they asking you. He wants to build a bookshelf, okay? He has an office that's 12 feet by 15 feet. The shelf is going to go along the entire wall of one side, so he's going to build it the entire length, and it's 1 foot deep. So, should he put it against this wall, the shorter wall, or should he put it against the longer wall in order to have the most floor space, so the most space inside? So, you can think of it, so here, let's say, is the bookshelf, and it's 1 foot deep, so it's going right against the wall, but there's a foot of space here, because it's a foot wide, you can think of. So should he put it there? Or should he put it here, against this wall? That's really the question. Should he put it against this wall, or should he put it against that wall? And he wants to have the most floor space that he can. So, since he wants to know how much space he has here, this is an area problem. So we just need to figure out how much floor space he has if he puts it against that wall versus how much floor space he's going to have if he puts it against this wall. So, again, it's just an area problem. We have a rectangle, so we're just going to figure out what is the area of that space. So he puts the bookshelf on. We still have, this is still a rectangle. So we're still going to find the area by length times width. We just need to figure out what is the length and what is the width. So here, our length, we lost a foot because that's the bookshelf. So the bookshelf is covering the floor. You can't use that floor space. So if this is 1 foot, it used to be 15 feet all the way here. This is 1 foot. So 15 minus 1 foot. Our new rectangle is only going to be 14 feet long because we've cut off a foot over here. Now the width, we haven't cut anything off. This is still 12 feet from top to bottom. So our new rectangle just is 14 feet by 12 feet. So what's the area of that rectangle? You do the same formula, length 14 times width 12. So you can plug that into your calculator and you're going to get 168 feet squared. So if he puts the bookshelf against the shorter wall, the 12-foot wall, this is how much floor space he's going to have. How much floor space is he going to have if he puts it against the longer wall? Well, now we want to show what's the area in here. So the length, he hasn't taken anything off of the length, so the length is still 15 feet. But remember, this is a foot wide, the bookshelf is a foot wide. So now we've lost a foot. Here we had a 12-foot wall, but we've lost a foot. So the area of this rectangle is still 15 feet wide, or long, but now it's only 11 feet wide because we lost this foot there. So 12 minus 1 is 11. How do you find the area of that? Same formula. Area equals length, which is 15, times width, which is 11. You put that into your calculator, you're going to get 165 feet squared. So, if you want to maximize floor space, which means you want the most, if you put it against this wall, you'll have 168 feet squared. If you put it against the longer wall, you'll only have 165 feet squared. So, you want to put it against this wall here, because that will give you the most floor space. I'm going to take a pause and put another question up. Alright, we have another question here. Earl wants to cover a bathroom floor with tiles. The floor is 5 feet long and 2 feet wide. Each tile is a square that measures 4 inches on a side. So how many tiles does he need? So he has a bathroom floor. It's 5 feet long, 2 feet wide. He's going to cover it with tiles, so you should automatically think about area because we're talking about covering something. So the tiles are 4 inches on a side. So here's the first thing you always want to look for is units, because you can only compare like units. Here are feet. These are inches. So the fundamental question is, you have these tiles which are small, and you're going to put them side by side until they cover up the whole floor. And the question is, how many of these tiles do you need? So, before we can work on this, we're going to put each of these units into the same unit. We can't have feet here and inches here. So, you can do this however you want to. You can either put everything into feet or you can put everything into inches. I personally think it's always easier to put things into the smaller unit. So here, inches are smaller than feet, so let's change everything to inches. So, we're going to change this into a rectangle of inches. So, you need to know, and this you need to memorize, is that there are 12 inches in 1 foot. So if there's 12 inches in 1 foot, how many inches are there in 2 feet? Well, it's 2 times 12. So this is 24 inches. So if this is 5 feet, how many inches is it? 5 times 12 is 60. So this is 60 inches. So now we can go with the problem because we have these tiles. Remember, these tiles are each 4 inches, each side is 4 inches on the tile. So now we can continue. So that's one way that they're going to get you, is by having different units of measure. And a lot of people would just find the area of this, it'd be 10, and that's not what you want to do. So always change to the similar unit. I always generally change to the smaller unit because that way you can just do a multiplication and you can get the right units. I mean, we could change this to feet, but then you have 4 inches is a third of a foot. So unless you want to work this problem in fractions, which you can, if you're comfortable in fractions, that might be better for you. But most people would rather work in whole numbers. So, we have the bathroom. It's 24 inches by 60 inches. We have these tiles that are squares, 4 inches on each side. How many do we need? So the first thing we're going to do, what is the total area of your bathroom? So again, you go to the formula, length times width, 60 times 24. You plug that into your calculator, and you're going to get 100 or 1,440. And again, we're working inches squared. So that's the total area of the floor. You have these little tiles that you're going to put in here. And so what's the area of one of these tiles? Well, it's a square. The area for a square is S, or side, squared. So 4 squared. So the area of one of the tiles is 16 inches squared. So if you need to cover this much, and each one of them is 16, how many do you need in total is a division problem. You divide your total area, 1,440, divided by the area of one of them, which is 16. You plug that into your calculator, and you're going to get 90. So the number of tiles that you need is 90. So some key things here. Always work in the same units. So translate the different units to something similar. Here we translated them all to inches. We translated the 2 feet to 24 inches, 5 feet to 60 inches. Here we need to cover this whole area, so we needed to find out what is the area. That was this. One of these little tiles is going to cover 16 square inches of that. So in order to cover all of it, it's just a division problem. That divided by one of the tiles tells us how many tiles we need. We're going to do one more problem, so I'm going to pause and put it up. Okay, here's one last problem. You want to put a sidewalk around a swimming pool that is 50 feet by 30 feet. So if you don't recognize how they're writing this, it might be written like that, where they put an X for the by thing. The sidewalk is 5 feet wide. What is the area of the sidewalk? So, I'll read it again. You want to put a sidewalk around a swimming pool that is 50 feet by 30 feet. The sidewalk, has a width to it. It's going to be 5 feet. So what's the area of the sidewalk? It's always good to draw a picture. So we have a pool, 50 feet by 30 feet. We're going to put this sidewalk around it. And the sidewalk is going to be 5 feet. So from there to there is 5 feet. This is 5 feet. 5 feet. It's not drawn to scale very well. But each side is 5 feet. And what we want to know is, so what is the area of the sidewalk? So there's 2 ways to solve this problem. Probably more than that. There's often more than one way to solve a problem. So I'm going to show you 2 ways, whichever way that you would think about it better. So you can see it's kind of like a picture frame around the pool. But we don't want the area of the pool, we just want the area of the picture frame, if that's how you can think about it. So what we're going to do is find the area of this whole rectangle, the bigger rectangle, and then subtract out the area of the pool. That's one way to do it. So how do we figure out what the area of this larger blue triangle is? Well, remember, from there to there is 50 feet, but then there's an extra 5 feet over here and an extra 5 feet over here. So the whole length of this blue line from the end of the sidewalk to the other end of the sidewalk will be 50 plus 5 plus 5. So the outer blue, I'll write it in blue, blue triangle that includes the sidewalk is actually 60 feet. Because we had 50 for the swimming pool, right? They gave us that. Then we added 5 feet of sidewalk on to this side, so that's 50 plus 5, and then we had 5 feet on the other side, so there's another 5. So 55 plus 5 is 60. Going this way, remember we had 30, and then we're going to add 5 up here, So there was 5 up here, and there's 5 down here, because the length of the width of the sidewalk is 5. So we have 30 there, plus 5 is 35, plus another 5 is 40. So the outer rectangle that includes the sidewalk, the length is 60. So the area is, the length is 60, and the width is 40. So the area of that bigger rectangle is 2,400 feet squared. So what we said is, the first way we're going to solve this is we're going to take the big blue, the whole area of this, and we're going to subtract out the area of the swimming pool. Because if we subtract that out, we'll be left with the sidewalk. So what's the area of the swimming pool? Well, we already know that. We know that area is length times width, and they told us it's 50 by 30. So it's 50 by 30 is 1,500 feet squared. So if we take the big rectangle and everything in it, 2,400, subtract out the swimming pool, 1,500, we're left with 900 square feet. And that is the length, or the area, sorry, of this outer sidewalk, because we took everything, subtracted out the middle swimming pool, and what we're left with would be the area of the sidewalk. So that's one way to solve this problem. The other way is to do it in pieces. So again, we have our swimming pool, 50 feet, 30 feet, and then we have the sidewalk, which is 5 feet around on each side. So here, instead of finding the area of the big rectangle and subtracting out the smaller rectangle, we're going to do it in pieces. And we're only going to deal with the sidewalk. So we're going to just look at from here, we're going to like cut that off and just say, okay, what's the area of that little rectangle there? Well, again, so we know from there to there was 50, and then we added 5, and then we added 5. So that little rectangle, just this one down here, the length is 50 plus 5 plus 5, so we know that's 60. And we know the width of the sidewalk is 5. So just this little area down here is going to be 60 by 5 equals 300. And we know that this is going to be the same area up here. These are going to be equal because that's what a rectangle is. So if we have 300 square feet here, this is going to be 300 square feet. So we're going to add on another 300 square feet. So far we have a total of 600 square feet, but we haven't added on these two yet. So what's the length, or what's the area, sorry, of these, let's just do this one right here. Well, we know that, so now we have this triangle. We know that from there to there is 30, because we don't need to come out here. We've already counted for the area out here in this one, so we don't want to double count it. So we just go from there to there is 30, and we know that this is 5. So the area is 30 times 5. That's 150. And we know if this area is 150, then this area is 150. So we're going to add that on. So we have a total of 300 feet squared. So we had 600 from that one and that one, and we had 300 from those two. So we know the area of the sidewalk is 900 feet squared, which is exactly what we got over here. So you can either take the whole thing, subtract out the swimming pool, or just look at these rectangles in pieces and do them individually and then add them all up. And you're going to get the same answer.